Picture this. A single skyscraper demands 1,000,000 hours of human labor. That's like one person working non-stop for nearly 5 centuries just to raise one building. Over 1.5 million metric tons of steel and concrete form its backbone, a gargantuan skeleton that braces against daily wind and seismic jolts. How do you even begin coordinating that kind of colossal task? Before a single bolt clicks into place, over 200,000 architectural drawings must perfectly align the steel, glass, and all the intricate mechanical systems. It's a feat of staggering precision engineering. Then comes the real human story. Thousands of workers, spanning 20 to 30 different trades, converge on site daily. Imagine that incredible choreography of concrete, cranes, and raw nerve. The structural core alone requires 100,000 cubic meters of concrete, enough to pave a 100-kilometer, 2-lane road. It's truly a monument to human persistence. But what's the price of this ambition, the unseen army? Before any steel even rises, vast foundations sink, sometimes 100 meters deep. That means excavating 500,000 cubic meters of earth, enough to fill 200 Olympic swimming pools. The skeletal backbone of these titans can be over 80,000 tons of structural steel, hoisted and bolted piece by piece. A typical skyscraper then consumes 300,000 cubic meters of concrete for floors and core walls, enough to pave a 4-lane highway for 200 kilometers. Cladding the exterior involves thousands of workers installing 10,000 to 15,000 glass panels, often at dizzying heights. And deep inside, hidden behind the aesthetics, lie hundreds of kilometers of electrical wiring and over 150 kilometers of complex plumbing networks, enough piping to stretch from London to Dover 3 times over. Building just one skyscraper demands over 1,000,000 hours of labor. That's 100,000 days of relentless work. This massive undertaking is a masterpiece crafted by a truly global crew. Imagine ironworkers, 500 meters up, wrestling 15-ton steel beams, each weighing as much as 2 garbage trucks. Down below, concrete teams are mixing and pouring an astonishing 80,000 cubic meters, enough to fill 32 Olympic swimming pools. Then there are the electricians and plumbers, laying more than 500 kilometers of wiring and piping, creating the building's intricate nervous system. Architects and engineers pour 40,000 hours into design, running simulations for wind loads that could make a lesser structure sway by 0.5 meter. Overseeing it all, project managers juggle up to 50 subcontractors, orchestrating complex projects that cost more than $2 billion. It's a testament to collective human effort, spanning years and bringing together thousands from over 20 nations. Every single person working on these giants is literally building their own story into the skyline. If you're amazed by how we construct the future, hit that subscribe button. Think about the sheer ingenuity in pumping concrete over 600 meters high for the Burj Khalifa. It demanded extreme precision and expertise. That alone required specialized mixes that could hold their integrity under immense pressure. It's just one piece of the advanced engineering that turns theoretical skyscraper designs into colossal realities. Consider the logistical ballet involved. Hundreds of thousands of structural bolts, each inspected for exact tension, securing sheer masses of steel. We're talking over 300,000 bolts for a single tower. And the cranes hoisting these massive components? The world's tallest tower cranes can lift a staggering 25 metric tons to heights over 800 meters. That's heavier than a dozen cars, lifted hundreds of stories high. The operators in tiny 2-square-meter cabs, perched over 800 meters up, must have nerves of steel. A single skyscraper like the Shanghai Tower uses 106,000 metric tons of steel. Enough material for 3 Nimitz-class aircraft carriers. The precision for welding is also insane. Welders connect beams with a tolerance of just 2 millimeters, hundreds of meters up. It's like performing surgery during a gale. The shimmering skin of the Burj Khalifa, for instance, comprises 26,000 custom-cut glass panels. These aren't just windows, they're a sophisticated facade deflecting the harsh desert sun. Even counteracting a skyscraper's sway is an engineering marvel. Taipei 101 employs a 660-ton tuned mass damper, a colossal golden pendulum visibly swinging on the 88th floor. And anchoring these giants? Foundations often involve 192 concrete piles, each driven over 45 meters deep. That's longer than a blue whale. This is essentially battling gravity with pure ingenuity. Picture this. A single colossal skyscraper, a former construction site, now pulses with the lives of 10,000 people, a whole vertical city. That immense structure chews through over 50,000 megawatt-hours of electricity each year, powering roughly 5,000 average American homes annually. For fire safety alone, it boasts over 40,000 sprinkler heads, all linked by 150 kilometers of piping. Seriously, that's enough to stretch across the continental United States. Its elevators shoot upwards at 25 meters per second, actually faster than Usain Bolt's top speed. You'd probably still miss every single one every morning, of course. Getting water to the highest floors means a whole series of massive pumps, forcing 946,000 liters of water through the building daily. Think of the HVAC system as its lungs, circulating over 1.5 million cubic meters of air every single hour. This vertical metropolis produces about 15 metric tons of waste daily, all managed by a secret network of chutes. It's less a building, more like an atmospheric habitat module clamped onto a tectonic plate, at least for now. Its observation decks draw over 1.8 million visitors annually, creating yet another city within this city. Inside the walls, hundreds of kilometers of cabling snake through. That's enough to wrap around the Earth 2.5 times. We evolved opposable thumbs and big brains, and we used them to build artificial mountains for filing paperwork. A single iconic tower can host companies with a combined yearly revenue exceeding $100 billion, a truly massive economic engine. Ultimately, these aren't just piles of steel and glass. They stand as testaments to 1 million hours of intense shared human ambition. Try explaining that level of coordination to your family reunion. These aren't just buildings. They're beacons of aspiration, symbols of progress. The Freedom Tower, at 1,776 feet, stands as a deliberate monument to American independence. It's fascinating how construction keeps pushing boundaries, from pumping concrete 600 meters up for the Burj Khalifa to exploring advanced carbon fiber composites. Some now reach 828 meters, nearly a kilometer into the sky. To accommodate our planet's growing population, many modern towers are designed for LEED Platinum certification, cutting energy consumption by 50% with advanced Ichaxan glazing, crucial for our future carbon footprints. These vertical cities can house up to 20,000 people, helping to ease urban sprawl. You struggle to fit 4 people in your car. Imagine 20,000. A single project can generate over 10,000 indirect jobs, sustaining local economies for years, from material suppliers to food vendors. Science continues to advance, with self-healing concrete reducing maintenance costs by 30% and transparent aluminum for stronger windows. These towers are becoming nerve centers, integrating 5G, smart sensors, and AI climate control. Scientists actually built a city inside a building that listens. Some future designs will even feature vertical farms, producing 10 times more food per square meter than traditional agriculture. Think about that. A farm in the sky. Modern towers must also withstand Category 5 hurricanes at 252 kilometers and seismic shifts up to 8.0 magnitude, thanks to advanced dampening systems. Architecture evolves too, moving from rigid boxes to twisting organic forms. Evolution looked at steel and glass and said, "Let's make it dance." These monumental structures inspire hundreds of thousands of architecture and engineering students worldwide annually. They dream of building tomorrow's vertical worlds.